Okay, this section is on 3.6 chain rule. So we're going to explain to you the process of the chain rule. So chain rule you only do if you're taking a derivative and you need to use the chain. That's the only time really you need to do this. So for example, like this problem right here, it's actually a UV problem. Can you see that? This right here is going to be my U and all of this is going to be my V. So when we did the 7 rules for the differentiation, that's exactly the same thing as the trig rule that we used in the last section. When we need the chain rule, that's when we use it. So we're going to take the derivative of this right here. So in multiplication, I copy my u, so I have is x to the 4th, and I take the derivative of v. Now this derivative of v, this is where the chain comes in. Because I have a layer on the outside right here, that 3, and then the layer inside, that's when I'm going to use my chain right there. So I'm going to bring the 3 down right there. That gives me the 3 parentheses x cubed, right? Minus 1 to the 2nd power, because I subtracted 1 from there, times, because when we do the chain, we always multiply, and then the inside layer. So x to the 3rd right there will give us 3x squared. Derivative of negative 1 is a constant, so that's 0, so we don't have to worry about that part. And then plus, because it's multiplication, right? We go the opposite direction now. We start with the v, so x to the 3rd minus 1 to the 3rd. Derivative of u, so which becomes 4x to the 3rd. Okay, so that's right there was the derivative. So I did my uv off of this right here. So now I just need to simplify. So anything that has a single exponent, I can bring it up in the front. Oh, I think I can close my parentheses right there. Okay, so I can bring this one up in the front. I can bring the 3 up in the front, and then I can probably combine the x to the 4th to x squared as well. So let's do that. So I have is the 3 and the 3, so that's 9, right, because it's multiplication. Then x squared times x to the 4th will give me x to the 6th, because when you multiply, you add exponents. And then I can just copy the x to the 3rd minus 1 to the 2nd power. I think that's the only thing I can simplify for this first part right there. So now it's plus, only because of this plus right there, so that's plus right there. So the only thing I can do is, I don't think I can even do anything with that. So I'm just going to bring the 4x to the 3rd up in the front. So we have this 4x to the 3rd, parentheses, x to the 3rd minus 1 cubed. And I don't think I can combine like terms or anything like that. You may be able to factor out these parentheses, 2 of those guys right there, but I wouldn't even touch that part. I would just leave it as it is right now, okay? So let's try another example now. So example number 2. So example number 2 has something like this. It's a fraction. So what I want to try to do is change this obviously to an exponent, and we want to bring this one up because the only purpose of really using the chain rule is because if it's in the bottom, you can actually bring it up. Okay, so let's rewrite this problem. I have y equals then x plus 1 to the half power, because the square root turns into half. Now remember, this is an exponent of 1 right there. If it's an exponent of 1 and I bring it up, this becomes now x plus 2 to the negative 1, right? Because that's the algebra 2 part of it, which is bringing things up right there. Okay, now this becomes a uv problem again. So here's our u, here's our v. So we have then as y prime is equal to, we start with the u. So I copy my u, x plus 1 to the half power. I take the derivative of v. So this is where the layer happens. I have a negative 1 on the outside. We bring it down, and then we go on the next layer, which is this part right there. So I have is the negative 1, x plus 2 to the negative 2 now, right? Because I'm subtracting 1. And then the derivative of the inside, the x is 1, derivative of 2 is 0. So I probably won't even need to bother to put that 1 right there. All right, and then plus, go the opposite direction. So now we have is x plus 2 to the negative 1. And then the derivative of this part, again, that's going to be the chain. So I'm going to bring the half down, right? So that's going to give us the half right there, parentheses, and I copy the x plus 1, the negative, I minus 1, half. And then again, I would take the derivative of the inside, that x is 1, derivative of 1 is 0, so I don't need to bother with that as well. So here we are, that's the first derivative. Okay, so now to simplify, I think the only thing I can do on this part right there is to probably just bring the negative 1 up in the front. And everything else, we're just going to have to leave as the exponents as it is. So then I have is negative 1, which I don't even need to put the 1. I just put negative x plus 1 to the half power. Then we have is x plus 2 to the negative 2 power, right? And then I have, on this case, I think the half is the only thing I can bring up. So let's go half. And then I have is x plus 2 to the negative 1, and then x plus 1 to the negative half. Okay, so then I believe that's all we can do. Again, you can maybe factor things out, but I don't think we can even factor things out because that's a positive half and that's a negative half right there. So I wouldn't even touch that as well. So that's going to be your final answer right there. Okay, now let's do a third problem, a little bit more challenging problem. So I'm going to use the whiteboard because I'm going to erase things as I go along here. Okay, so the first part is changing things and making sure you have enough parentheses. So the first part right there I have is x to the 5th right there on the cotangent right there. I'm going to rewrite that problem. So I then have is y equals 1 plus cotangent. I'm going to put that on the outside right there. X to the 4th plus 1 parentheses to the 5th, parentheses to the 9th, like that. So in pre-calculus we learned that if you have an exponent inside right there, you can always put a parentheses right there, right, and take it out to the 5th power right there. Okay? So now using this, we're going to go ahead and take the derivative. So y prime equals. So the first layer of this is bringing the 9 down. So if I bring the 9 down, I have is 9 parentheses, and I copy everything that's inside that parentheses part of it. So x to the 4th plus 1 to the 5th power, and then minus 1 will give us 8 right there. Okay? Now, I'm going to erase this so you can kind of see where the layers happen. So if I erase that first layer right there, which was that 9, I erased that part right there, I'm left with is something like this. So I have then is the derivative of 1 is 0, so now I'm done with that one. The next layer for the derivative of this is this 5 right here. So I'm going to bring the 5 down right there, right? So it's multiplication, so we multiply by 5, and then we copy the cotangent, x to the 4th plus 1 to the 4th power now, right? Because we subtracted 1 from the exponent right there. Okay, times, and now this is going to be really long, so I'm going to have to do it underneath here. But let me take that layer off so you can see we're done with that layer right there. So if you're done with that layer, we're done with the 1 and the 5 right there. So you're left with is just this piece right there. So the next layer is then the derivative cotangent, right? So derivative cotangent is what? Negative cosecant squared, right? And then we copy the x to the 4th plus 1 right there, because again, this layer is what you worked on, which was the negative cosecant. And you have to copy all of this piece right there, which is this piece right there. Okay? Times, and then we take off the cotangent because that was the layer that we just did right now. So now you're left with is the layer of x to the 4th plus 1. So derivative of x to the 4th will give us 4x to the 3rd, and then derivative of 1 is 0. So we're done with that now. So we're done with this, all of this right here. So the original problem was this up here, and so now we're done with the layers, okay? So it comes out to something like this. So now I just need to make sure I simplify. So when I simplify, because remember this is all multiplication right here, so I have this negative I can bring up in the front. I have a 9 and also a 5 that I can bring up in the front. So then I should have is what, negative 45. So that comes up in the front. I could probably bring the times 4x to the 3rd up in the front. I don't think there's any more x's, so I can't combine any of those. Remember, anything that has a single exponent on the parentheses can mingle. So if they're not single, they can't mingle. All right, so then this is gone. Probably could bring even the cosine squared then. Will probably be the next one up. So x to the 4th plus 1. And then probably the cotangent right there. So we want to bring the cotangent, x to the 4th plus 1 to the 4th power, right? All of that. And then all of this piece right here. So I'm not going to rewrite that because I don't have enough space. So it's all of this right there will be in that spot right there. So again, I just brought the 9, the 5, the negative. That gave me negative 45. And then, oh, I could have actually multiplied to the 4 right there. Oh, so I could have multiplied this right there. That should give me one single number. So I don't have a calculator on me right now, so we'll just have you figure that out. So it's going to be negative, whatever that number is, x to the 3rd, right? Then cosecant squared is what we brought up to the front right there. And then cotangent, this right there, all of that's going to be brought up next. And then all of this first part right there to the 8th power, all of that gets put up here. Okay? So that's the simplifying part of this equation right there. All right, so now let's go ahead and try some of these chain rule problems.